Okay, so in this lesson, this is example 2 from page 285 on quadratic regression. So you have the data points on your left, as you can see here, and Desmos has plotted it for us. And it looks like it is not a linear, relationship at all. But we have a better way of just by not just eyeballing it, but better way of doing it. So what we're going to do is I'm going to fit in a expression. So I'm going to fit in y1 shift mx1 plus b, and here we go, mx1 plus b. And you notice here that when I draw a linear regression fit, I'm getting a r squared value of 0.9305. And from the yesterday's lesson, you guys know that this r value is called the regression value. And the closer this value is to 1, the better the fit is. So you can say that that is a reasonable fit. It looks to us right away that it feels like it is a very good fit. But I'm not happy with this fit. I'm thinking maybe there is a better fit than even this fit. So I'm going to try a quadratic fit. So quadratic fit, I'm going to do it the same way as I did the linear one. And so y1, and you enter the tilde function like that. Now enter the quadratic equation that you guys know from before, ax1 squared, and then you have bx1 plus c. So this is what you would call a quadratic equation, ax squared plus bx plus c. But because we are using the x1 and y1 from the table of values, instead of having y, we need to have y1, and instead of having x and x there, you need to have them as x1 and x1. And you notice something very interesting. This also, the r here, the capital R, is also called the coefficient regression, or the regression coefficient. And so you notice that the r squared value is 1. And here the r squared value is 0.9305. Since the r squared value is 1 here, this is what you would call a perfect fit. You cannot have a better fit than this. So what we find from this exercise is that for this set of data that we have here, when we try linear fit first, and then we try quadratic fit, we realize that the quadratic fit is the right kind of fit. And once you have a quadratic fit, you can find out all kinds of information about this relationship from the equation. For instance, if I like to know if my x value, right now the x value is going up to 2.6, and I want to know if my x value goes to, say, x value of 3, what will be my y value? So to do that, what we're going to do is we're going to plot the line. So when x equals 3, and x equals 3 is a straight line, and you notice here, the straight line here, the x equals 3, is meeting the parabola about there. Okay, so it's meeting the parabola there. And you notice that then the x value is 3, the y value is 44.837. So you can get the information about the x values that you want to know. And this, since I'm trying to find the value of x beyond the given data point, that is called a extrapolation. So I'm going to write that down for you. And so that would be the any values beyond this is called a extrapolation. And if you want to find values within the given data, that is called the interpolation. So let's try that. So we have values between 0 and 2.6. And if I want to find a value, say 1.3, that is not in the table of values, I can go x equals 1.3. It plots a line for me, and where the line meets the graph, right there, the line meets the graph at 1.3. I notice that the value of y is 8.4. 4, 5. And this is called interpolation. So interpolation is finding out information about the relationship within the set of given data, and extrapolation is finding out information about the relationship outside the given data. You need to know these two words, interpolation, extrapolation. I know that you've done this in your grade 9. Okay, so this is going to be on your quiz as well. There'll be a match the following question where you need to answer that. Okay, so these are the uses of using this is how you use Desmos to graph a table, and you can do interpolation, extrapolation, you can do regression fit, and so on.